In 11.3, our first definition is not in our book, but it's something that Miss Olson and I thought was important that you know. You need to know what irrational numbers are, okay? So in all numbers, okay, they're either one of two things. They're either rational or they're irrational. Most numbers are rational. All whole numbers are rational. All fractions are rational, 2/3, 1/2, decimals like 0.5. Those are all rational numbers, negatives included, okay? Irrational numbers are numbers that cannot be expressed as the ratio of two integers. This is the technical definition, okay? How you're going to recognize it is that when it's in decimal form, an irrational number has an infinite number of digits and doesn't show a repeating pattern. So basically, it never ends and it never repeats. And pretty much the only time that you're going to see this is with square roots. And that's when you take the square root of a number that's not a perfect square. For example, the square root of 8. We know that the square root of 9 is rational because that equals 3. However, the square root of 8 equals, when I type it into a calculator, 2.8284271. And actually, when I type that into the calculator, this is only part of the decimal. It actually continues on forever in a non-repeating pattern. So it never ever repeats, never shows a pattern, and it never ends either. So irrational numbers basically when you get that square root of a number that's not a perfect square. Now, how is the area of a square related to its side length? Well, when we look, there's two ways to look at it. When we look at a square, all the sides are the same. So the area will be side times side, or side squared. Okay, so side times side equals area. Okay, actually let's use an uppercase A. Now, if I'm given the area, s squared equals A, and I want to know the side length, I'm going to square root each side to tell me that side equals the square root of the area. So for example, if I have a square of area 3 and I want to know the side length, the sides are all going to be the square root of 3. Okay? So our first example, we're going to find the area and side length of each shape. We're going to do a square first. Squares are easy. How we want you to do this at first is we just want you to use the boxes. So from here to here to here to here is a box. Okay, and we're just going to call that one square unit. Okay, so we've got 1, 2, 3, 4 of those. Okay, and then if you look, we've got a triangle here that when added to this triangle, if I think about rotating it, if I added this chunk over here, it would make 3. Okay, so together with this triangle and this triangle, we've got 3 more. Okay, so between those we've got 3. Same thing with these, we've got 3. Okay, so we've got 4 plus 3 plus 3. That gives us an area of 10. And if I want to know the side length, I just need to take the square root. So the side length will be the square root of 10. This is an irrational number. It says which of these is irrational? This number right here is our irrational number, because when I take the square root, that's not a perfect square. Okay? Next one, side lengths, pretty easy. 1, 2, 3. 1, 2, 3. Okay? And the area of a triangle is base times height divided by 2. So 3 times 3 divided by 2. Okay? So 9 divided by 2, that means my area is 4.5 square units. Let's use square units. And the last thing I need to do is find this side length. Okay? what we're going to do is we're going to use squares. So I'm going to go to my next page. I'm going to redraw this on a piece of graph paper where I can see a little bit more of the picture. I had a 3 by 3 triangle. Okay. And what I'm going to do is I'm going to make a square off of this side. Okay. So where this went down 3 over 3, I'm going to do the same thing. 3 and 3. Oops. Yep, to make my next side. Same thing here and here. So I want to find the area of this. 1, 2, 3, 4, 5. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So my area of this square is 18. So that means that this length right here, okay, is the square root of 18. The square root of 18 is also irrational. Okay? So I would like you to try this same problem for class. It's going to be a little bit more complicated. Do your very best that you can. Get as much of it done before you come back into class on Friday. And you might need to copy this down onto a different piece of graph paper, this triangle, to help you figure it out. Some of you might be able to do it in your head, or some of you might remember the Pythagorean theorem, and that might help you. Okay?